Okay. Um, good morning, good afternoon, good evening, everyone, depending on where you are. Welcome to TGIP monthly project updates. My name is CJ Guo. I'm one of the co-founders and CEO of StreamNative, and I'm also one of the PMC members of Pulsar and BookKeeper. And so monthly project updates is a webinar that is hosted by StreamNative, and we want to use this chance to kind of give the entire Pulsar community kind of a project updates around Pulsar StreamNative products and also around the entire Pulsar ecosystem. And if you have any questions, feel free to kind of use the Q&A panel to write any questions or use the chat. You can use the chat tools to send any chat message as well. And I can answer those questions along the presentation at the end of the presentation. And thank you again for attending the monthly project update. Usually before I get started, I want to kind of use the first couple minutes to go through a couple large events that is happening in the Pulsar community. So obviously, as some of you probably already know, that we are going to hold the Pulsar Summit North America in 2021 in June 16 and 17th. The call for presentation is already closed last week, and we have received more than 60 talk submissions, and it kind of reached a new milestone for Pulsar Summit. Last year we received around 40 talk submissions, but this year we kind of increased by 50%. So it's a new milestone. And right now the program committee is working on selecting the talk submissions. We try to kind of select the best talk presentations so we can have a very good schedule finalized in a week also. And so just like watch out on our Twitter channel, like Slack channel, we would announce the schedule in a week also. But still the registration is still open. If you're interested in attending the summit, you can use the hop-in links to sign up. So Pulsar Summit is coming in 2 months. The next one is Pulsar Hackathon. This event is the first event, first ever like hackathon we organized, and we have already received about kind of more than 60 people sign up. Our team prepare for the hackathon, but just want to kind of advertise this event again. The registration is still open. The deadline for kind of sign up is April 28th, and the actual hack days will be on May 6th to 7th, because it's we are receiving, so we have people coming from different time zones, so it's really hard for actually let me see. Okay, so yeah, I can send the link address. Yeah, so oops. Okay, you can see the kind of the sign up links in the chat panel. The the hack days would roughly around like May 6th and 7th. And during these 2 days, you can hack any ideas. And we recommend people to submit a final demo video. So we have a judge team that is able to review your hackathon work and be able to select a winner. And we will announce the winner in at the Pulsar Summit North America 2021. And so you can hack any idea that is related to Pulsar. It can be the core Pulsar itself, like you want to add new features to Pulsar, make a huge enhancement within Pulsar. You can do integrations, like if you want to develop a connector with Druid, Pinode, you can develop any integrations between Pulsar and any other system in the larger big data ecosystem. We also have a dedicated session is related to Pulsar and Flink integration. So if you have any ideas related to how to improve the Pulsar and Flink integration, you can also do any of those projects as well. Another category is around running Pulsar on cloud in cloud native environment. So anything related to deployment, operators, and like auto scaling. So those would be kind of interesting topics that you can use for as a project to do in Hackathon. And I also want to kind of let you know is we have a monthly office hour, and the office hour for this month is happening next Wednesday. It's at the same time, 12 p.m. Pacific time. That office hour would be dedicated to Hackathon. So if you have any questions related to Hackathon, feel free to join the office hour. At the end of this presentation, I will also show the link and to the office hour, so you can sign up there. And we have another Pulsar meetup, Pulsar Plus Flink meetup coming up this month. Is it happens on April 28th, 2021. And the presentation is coming from Jerry Peng from Splunk. He's going to present how Splunk built real-time stream processing engine using Pulsar and Flink. And this is the sign up link. So I'm also copying the link in the chat panel. So if you're interested in this topic, feel free to sign up. So as you can see here, we have pretty good community events that is coming up in a week, in a month, in a couple months. So if you're interested in any event, or if you're looking for more events and we didn't show up here, feel free to reach out to me, to any people in the Pulsar Slack channel. So to get started with this month's monthly project updates, I want to first share like one major feature release in StreamNative Cloud. That is, we bring in a managed Flink offering as part of StreamNative Cloud offering. And the aim, like StreamNative, is we want to combine Flink and Pulsar together as real end-to-end streaming solution. So this is a diagram showing our visions and what we are building within StreamNative. So the the solution is basically combining Pulsar and Flink together, and Pulsar would be serving as a unified batch in stream storage, and Flink would be served as a unified batch in stream computing engine. And what it basically, all the functionality it provides is that through Pulsar, you are able to connect a bunch of different data sources. You can ingest data using different protocols like the native Pulsar protocol, or you can use the protocol handlers like Kafka on Pulsar, AMQP on Pulsar, MQTT on Pulsar. So you can ingest the data using different popular messaging protocols and ingest data into Pulsar. And Pulsar is able to store the data in tier storage. If you run the tier storage can be S3 on AWS, GCS on GCP, or Azure Blob Store on Azure. So it would use all the cloud native storage as the tier storage for keeping data for as long as what you want the data to be around and to be queried. And then you can apply Flink as the unified batch and streaming query engine to process the data and produce continuous results. And those results can be like dumped into an external system using Pulsar sync connectors. Like you can use Elasticsearch connector to write the result back to Elasticsearch. You can use a Snowflake connector to write the result to Snowflake. Or you can use Pulsar's PubSub API to consume those results as well. So that is kind of the vision that we want to like offer as part of the StreamNative Cloud offering. And in the recent our cloud release, we introduced Flink Circle as part of our offering. And this is a diagram showing how we bring in our Flink Circle into our offering. So within StreamNative Cloud, it contains two parts. One is a StreamNative control plane, and the other one is we call StreamNative Cloud Pool. The Cloud Pool can be a Kubernetes cluster that is running in StreamNative Cloud account, or it can be a Kubernetes cluster that running in customers' cloud accounts. And customers is interact with StreamNative control plane through its RESTful API or Cloud Console. And when it receives any requests that need to create a Pulsar cluster or a Flink cluster, then it will talk to the cloud pool, and the operators running within that cloud pool would react to those the creation request and create corresponding Pulsar cluster or Flink cluster, and those operators would be running on monitoring the healthiness of individual cluster and react to any failures and ensure the system is up running well. So this is an overview about how we kind of building out our StreamNative Cloud. And next, I will kind of showing you how we kind of bring in the Flink offering into StreamNative Cloud. So the first part is about like provisioning. Since our entire solution is built on Kubernetes, then the control plane would create a CRD in the StreamNative Cloud pool, and the operators running in those pools would react with monitoring those CRD and create corresponding Flink cluster based on the specification specified in the CRD. So all as you can see here, the kind of the API and the actual CRD that create Flink cluster is kind of decoupled, and so the StreamNative control plane only maintain those metadata, but the operators running in the cloud pool is doing the actual work, and they are connected via the configuration. And once you have the Flink cluster is up running, then the user can establish a connection through our Cloud Console, and the Cloud Console would kind of create a connection to the Flink cluster through a circle gateway. And once the connection is created, then the user is able to send the query result, send the query request through our Cloud Console, and those circle query would be sent to circle gateway, and circle gateway would pass those streaming circle queries and issue a Flink job to the Flink cluster. And once the Flink job completes the processing the data, it would send back the query result, and those results would be displayed in StreamNative Cloud Console. So that is the interaction part. And one thing I want to highlight here is the how Flink interact with Pulsar is through the open source Pulsar Flink connector, and that connector is being right now is open source and maintained by StreamNative, but it's also being contributing back to upstream Flink. So we are expecting to see the Pulsar Flink connector available in the main Flink repo in next Flink release. But right now, the StreamNative offering is based on the 2.7.0 Pulsar Flink connector, and that connector supports like T-share subscription, exactly one semantic, and be able to treat Pulsar topic as an upsert changelog stream, and so you are able to leverage Flink to do those upsert operations in on Pulsar topics. And on the security part is that this diagram showing how we handle all the security between the Cloud Console and Circle Gateway, Flink, and Pulsar. As you can see here, we heavily rely on the Pulsar authentication and authorization. And when the Cloud Console initial connection with Circle Gateway, and the Circle Gateway would set up a possession Pulsar catalog. So each Pulsar, each Circle session would be run as a user. So all the user credential would be passing through the Circle Gateway, and the credential will be submitted to a Flink cluster. So when the Flink job is running, it will use the user's credential on accessing the Pulsar cluster. So in this way, on both Flink side, on both Circle Gateway, Flink side, and Pulsar side, we are able to track which user is actually running that circle query. So we are able to audit all the activities that are happening in the cluster. So all your circle query and the code you submit are all running in a controlled environment. So this is a kind of a brief, brief introduction about the kind of the Flink circle features that we're introducing in as part of StreamNative Cloud offering. And that feature is already available. And if you're interested in trying out this feature, you can sign up StreamNative Cloud and play around with this feature. And we also offer free credits. If you're looking for any credits, feel free to reach out to me on Pulsar Slack channel. And so this is the kind of the product update on the StreamNative Cloud side. And then I would dive into more on the Pulsar project side. So in last months, we have, I would say in past 2 weeks, or probably 3 weeks, we have successfully released 2.7.1 release. And it accumulated a bunch of the bug fixes coming from 2.7.0. And if you are using 2.7.0, or even you are using 2.6.2 and looking for upgrading your Pulsar cluster to 2.7, and I would recommend you deploy 2.7.1, not 2.7.0. Usually 2.7.1 is a bug fix release for 2.7.0. So it fixed a lot of bugs that has been identified from using 2.7.0. So that would be it would be seen as a more stable version comparing to 2.7.0. 2.7 is out, and if you're interested about that, what has been introduced, or what kind of the bug fixes that include, you can check out this. Oops, I don't have a link. You can check out these release notes, and I would also copy the release notes in the chat panel. So you can click the release notes and check out what has been fixed there. And then I would kind of dive into the major updates on Pulsar side in the past 4 weeks. So the first one is there is a major effort on improving the memory usage on the Pulsar client. That is the PIP 74. So if you have been using Pulsar client before, you probably already know on the producer side and consumer side, if you want to control the memory it used by the Pulsar client, there are 2 settings you can do that. One setting is on the producer side, you can control the pending queue size. And on the consumer side, you can control the size of the receiver queue size. But the problem of those settings is that the settings are in terms of the number of the messages. It's not based on the number of bytes. So one has to adjust based on the expected message size. That for example, if you say I config my pending queue size to be 10,000. If the average message size is 100 bytes, then it would be 10,000 would be just I would say a megabytes, 10,000. Yeah, a megabytes memory. But if you are receiving messages, average message size would be 1 kilobytes. Then the 10,000 1 kilobytes would be 10 megabytes. Sorry, my math is a bit wrong. Yeah, 10 megabytes. So 10 megabytes versus 1 kilobyte, 10 kilobytes. That is totally different. So it's really hard for people to realize like how you want to convert the size of the key, the length of the queue, map the length of queue to kind of the actual memory the client would use. So that is the first problem. The second problem is the setting itself is per producer and per consumer. So if the application has a very large number of the producers or consumers, or even you are consuming or you're producing to a topic that have thousands of 10,000s of partitions, because individual partitions, Pulsar client will create a producer object or consumer object for that partition. And in that case, then you would have 10,000 receiver queues. And so it will make things much harder to kind of to calculate the actual memory usage for Pulsar client. And it's also difficult to select what would be the right value for the queue size. So in order to solve the problem and to make things much easier for the users, is we want to see how we can improve the API. And the goal here is basically to allow user to just simply specify what would be the maximum amount of memory a client want to use. So in order to do that, we introduce a setting in the client builder called memory limit. And the memory limit is you specify the amount of the memory that would be allocated in use by the client. So this is an example. In this example is that I create a Pulsar client and I set the memory limit to 64 megabytes. That means the Pulsar client would try to use at most 64 megabytes. And if the memory allocation go beyond the request memory, then the send request or the consumer request would be blocked until memory being released and is available to allocate for new messages or be able to send a new messages. So that is the new API we introduced. And the underlying how we implement that is in the Java client, because the entire Pulsar Java client is leveraged native as the underlying networking library, and native has its own memory allocation library. So in the Java client implementation, we leverage native memory allocation to enforce the memory limit to the settings that is specified in the client builder. So if there's anything go beyond that memory, then the underlying native memory allocation will slow any exceptions, and the Pulsar client will catch those exceptions and apply necessary back pressure back to the application. So it will ensure that the memory usage will never go beyond the setting the user specified in the client builder. So this is how Java implement that. And but as you know, so people usually would ask if this setting also apply to other language clients. So right now, we only support Java and C++. And because C++ is implemented, so both Node.js and Python will also have the ability to configure those settings, because Python client and Node.js client are just a wrapper over C++ client. The Go client, I think the implementation of the memory limit is still under development, but it should be coming out soon. So that is the PIP 74. Then I move to a bunch of the, I would say, the highlights about the enhancement on both on the client side, schema, and the WebSocket. So on the client side, there's a enhancement on the consumer side is on when consumer using message listener to receive messages. There was a problem is if you are using message listener to receive messages from a partition topic, right before, I would say, I think this change is going to be released as part of 2.8. So I would say before 2.8, the consumers would only use one listener thread to process those messages. Then the problem of that is that if you are using a consumer to consume a topic with multiple partitions, then single thread would become the bottleneck because you are not able to, because all the messages has to be processed by one thread. That thread would become the bottleneck. You're not able to fully utilize the CPU resources within that within the client application. In this pull request, like 10017, we changed the behavior a bit. Is that for any topics, sorry, for when a consumer using a message listener, when it receives the messages coming from a partition topic, would use the partition name to dispute the messages instead of using the topic name. So with that being said, is that a message coming from one partition that might be assigned to different thread for processing. The benefits of this change is that if there's messages coming from one single partition, that is, it takes time for processing that message. It will not impact processing the messages coming from the other partitions, because the messages coming from different partition will be handled by different listener thread. And obviously, you can distribute the load across multiple listener thread, and you can also increase the processing throughput by increasing the number of the listener thread. But we still guarantee the ordering, because all the messages coming from same partition will be processed by same thread, and it would also utilize the entire CPU on your client application, and it would make our overall process much faster. So if you are using message listener and consume partition topic, so you definitely check out this pull request. It will be released as part of 2.8 release. The second client improvement, large client improvement, is the multiple topic reader supports reading multiple topics. So multiple topic reader implementation was introduced for reading messages from multiple partitions of one topic. But as you know, within Pulsar, a partition within a partition topic is exactly same as a non-partition topic. So if multiple topics reader is able to read multiple partitions of one topic, it should be able to support reading from multiple non-partition topic. And there was a use cases is for people, they want one reader to read multiple non-partition topic. So this change is able to provide that capability. So after this change, you are able to the multiple topics reader is able to support. You can specify a partition topic, then it's able to read multiple partitions of that topic, or you can specify multiple non-partition topics, or you can even mix it together. You can just specify a list of topics, no matter it's non-partition or partition topic. So this change would make a lot of use cases that is looking for building event sourcing applications using multiple topics much easier. So that is another major client change. The next one is related to schema. So as if you have used schema before, you know in Pulsar there's a schema called auto-consume schema. What auto-consume schema does is in the case that you don't know any schema prior to you write an application, but you still want to consume the topics and get the actual schema or get the actual objects coming out of that topic, you can use auto-consume schema. That auto-consume schema, what it basically does is it would talk to the broker and get us schema information of that topic and use the schema information to deserialize the message back into a generic record. So, but the initial implementation only applies to AVRO, JSON, those kind of struct schema. It doesn't apply those. It doesn't apply to schemas like string, a date, wrong, integer. So those kind of primitive schema are not supported by auto-consume schema, but there's a increasing demand on supporting auto-consume schema to consume to support all existing schema that is available in Pulsar. So in order to support that, we introduce an interface called GenericObject, which is used for represent all the objects that would be deserialized from the auto-consume schema. And the GenericObject is a wrapper over the actual data object. And that data object can be primitive types like string, bytes, byte buffer, date, or it can be a struct. That struct can be a JSON struct, an AVRO struct, or even a probab struct. And by using this, by changing the, by extending the auto-consume schema to return GenericObject, then you are able to use auto-consume schema to consume any topics within Pulsar. And what you get from the GenericObject is you are able to get what is the schema type of this object and what is the native object that you can get the underlying object. Like if it's a string, that you're able to get a string. If it's a JSON struct, then you can use the get native object to return the actual JSON struct. So you can use get native object to get the actual object, actual data object, and then you can process those actual data object based on the schema type and do your own logic. So that is the a schema change. That is, we introduce GenericObject and also enhance the auto-consume schema to be able to support also schema types. And the on the connector side, there's a fair amount of the work that has been done in the Pulsar Kafka connector. For people who may be new to Pulsar, maybe not use Pulsar Kafka connector before, the Kafka connector in Pulsar is pretty simple. Before this change, it basically just read the Kafka messages as a string and write the data back to write the data back to Pulsar. But if you have any schema information that is encoded in Kafka, like in Kafka, you have the AVRO encoded messages with conference schema registry, or you can encode the message using JSON format, even PROBAF or any other different serialization and deserialization mechanism that people use in Kafka side to serialize its data. So if you have any schema information in Kafka messages and you use the current Kafka connector, all the schema information will be dropped because the Kafka connector would just treat it as a byte, as a string. Then it would just write those raw bytes directly to Pulsar without any schema information. But that is not very useful if you want to kind of migrate your data from Kafka to Pulsar, because in Kafka you might already use conference schema registry to store all the AVRO messages. So in a recent change in the Kafka connector, it supports transfer all the AVRO encode messages from Kafka to Pulsar. With that being said, is that when the Kafka connector reading the messages from Kafka, it will also read the schema information from conference schema registry, because conference schema registry is also using AVRO as a standard to store the schema information. So we would just convert that AVRO schema information to Pulsar schema, and we upload that schema information to Pulsar. So once we set up the connection between conference schema and the Pulsar schema, we will transfer the data from the Kafka message to Pulsar message, and it would ensure Pulsar is able to interpret those messages as an AVRO messages. So in this way, all the schema information is carried from Kafka to Pulsar. There's no information being missed during this transformation. So that is a Kafka connector. But obviously, this is just, we just did this for AVRO, but there's a lot of additional schema information, such as JSON, PROBAF, and other primitive schema. Those schema are still not supported by Kafka connector yet, but there's an active group of committers are working on improving the Kafka connector. So hopefully by before releasing 2.8, we can get Pulsar Kafka connector into a pretty comprehensive state that is able to support all the schema, and that is able to transfer all the messages, including schema information from Kafka to Pulsar. So that is the Kafka connector updates. And the last one is related to Websocket. So WebSocket has been a very useful features for Pulsar, and it also supports the entire authentication and authorization that is supported by the normal Pulsar client. But WebSocket has a limitation. So a WebSocket has kind of two sides. One is the server-side WebSocket client that usually you are writing applications like Node.js, PHP, that is you are able to use the WebSocket client to issue a connection to a WebSocket server. But sometimes people want to write JavaScript using the browser WebSocket client. And there's a limitation on the browser WebSocket client because it doesn't support passing the HTTP header. It can only just connect to WebSocket URL. And because it's not able to passing any HTTP headers, but the Pulsar WebSocket implementation is expecting the authentication parameters coming from the HTTP headers. So that means I have Pulsar WebSocket available, but I want to develop a JavaScript application in my browser to talk to Pulsar, but I'm not able to do that. So in order to kind of get around this, the solution here is pass the authentication parameter as a query parameters. So you can append the either your JWT token as a token parameter as part of the WebSocket URL. So in this way, when Pulsar receive the request, it can get the token from the query parameter, and then kind of validate if validate this token and to see if it has permission to access the Pulsar resources. It's not the perfect solution because you are putting the authentication parameters as part of the query parameters, but it's the only solution for browser-side WebSocket in order for supporting browser-side WebSocket client. So it's a workaround, but it's not a highly recommended solution. So if you're using WebSocket, we are still recommend you passing all the authentication parameters from the HTTP headers. And the change is available as part of the 2.8 release. So that is the major product like features or enhancements that are happening in the core Pulsar project. And I would use the last 10 minutes to kind of talk about the ecosystem. So the first thing I want to introduce a new connector that is recently developed by us is Lambda Connector. That is connecting Pulsar with the AWS Lambda function. So what does this connector do is that it would pull the messages coming from the Pulsar topics and use the messages as the payload to trigger AWS Lambda function. So if you are using if you're already using AWS and you have a deployment on Pulsar, and if you want to use that Pulsar trigger that the messages coming into Pulsar topic trigger AWS Lambda functions, you can use this Pulsar IO Lambda connectors. So it's a sync connector, and it's also available as a it's open source under Apache license v2, so it's free for usage. So you can check out this link if you're interested in using this connector to connect Pulsar with AWS Lambda. So that is the ecosystem. I know it's we only have probably one large changes in the ecosystem. There might be other major changes that are still in progress because they are not complete. I'm not going to include in the project updates, but hopefully in the next project updates, I'm able to show some of the ecosystem update there. And at the before I going into the Q&A session, I just want to use this chance to kind of show the Pulsar office hour I mentioned in the beginning. So we have a special event for the Pulsar Hackathon. We will use the normal Pulsar office hour that would happening next Wednesday, 12 p.m. Pacific time for Pulsar Hackathon. So if you sign up Pulsar Hackathon and you have any questions around like Pulsar, if you want to get some of the ideas from our chief architect Edson, or if you want to discuss some of your ideas, feel free to sign up the Pulsar Hackathon for next Wednesday. I don't have the link in the slides, but if you are interested in this Pulsar office hour, feel free to reach out to me on Pulsar Slack channel. I'm happy to share the sign up link there. And as usual, actually I have probably, oh, yes, I have this link, so I can share the link in the chat. You should able to use the this link to sign up the office hour. But as usual, I just want to show we have every month we have 3 events. Like every the second Wednesday we'll do monthly project updates. The third Wednesday we will do a Pulsar office hour, and the fourth Wednesday would do free an hour free intro to Pulsar 101. So if you're interested in any of these events, feel free to sign up. And I think that's all from my presentation today. And if you have any questions, feel free to either raise your hand and I can unmute you and you can ask questions. You can use the Q&A panel if you don't want to speak. Okay, if there's no other any questions, then I would say thank you everyone for attending the project updates. Hope this this format is useful for to everyone. If you have any recommendation, suggestion, feel free to kind of reach out to me, and we are happy to incorporate your comments or recommendation to improve this format. And otherwise, I would say thank you to everyone, and depending on where you are, and good afternoon, good evening, good night, and thank you. Bye-bye.